we're writing the ground state electron configuration, and with a noble gas core of an ion of O+, that's oxygen plus. And again, we'll be entering it like we have in previous problems. Just a word about the term ground state as far as it refers to electron configuration. So ground state means all of the electrons are in their lowest possible energy states. And for us, what that means is they're going to occupy the lowest energy orbitals. And for example, 1s2 or 1s is the lowest energy sublevel in the lowest energy orbitals, then 2s, then the orbitals in 2p, etc., etc. And I'll do an example of something that's not in the ground state after I do this one. Now, whenever I do ions, I always start by doing the atom, and then I'll do an ion. And hopefully the reasons will become apparent as I work through a couple of these problems. For the oxygen atom, I go to my periodic table. Oxygen is element number 8. That means it has 8 electrons. And the noble gas core this time is going to be helium, which is just subbing for 1s2, then 2s2, and 2p4, 2, 4, 6, 8, that is 8 electrons. Then when you do the O+ ion, if it's positive, that means it has lost 1 electron. And it will always lose an electron from the highest energy sublevel. And the highest energy sublevel is always the one with the highest value of N. Where N is the number right here, N equals 2 for these. And then if it's got the highest value of N and you have 2 choices, then it will have the highest, basically P is higher energy than S, D is higher energy than P. Highest value of N, and then P is higher energy than S. Okay. So that means I'm going to remove 1 electron from 2p. My answer will be the same electron configuration, except it will be 2p3. Two S2, 2p3. Any questions about that?